I hear some people saying, I'm so confused right now. Part of this is because we started this question last time, and now I'm continuing it this time. Plus, there was the whole mistake thing, or the leading you astray thing. And I did skip over last time. It's pretty important that we see what's going on for how the actual formal part of how we came up with a function for this. Last time we just wrote this by saying, well, if the acceleration is 2.4 t, the velocity should be 1.2 t squared plus some kind of constant. Oh, what was that constant? Oh, it was 5. So we just did it that way. We're just formally writing out, if we want a function for velocity, in other words, if we want v of t, what we should do is say, as long as we have some initial value or a value somewhere, velocity at 0, plus whatever the change is from 0 to some variable t, that's a function for velocity. You can write it like that. Okay? The function for velocity is wherever you were at 0, however fast you were going at 0, plus the change from 0 to t. You were okay with it when it was 0 to 8. Like however fast you were going at 0, plus the change from 0 to 8, you were okay with that. But when this was a variable here, it's more difficult, especially with the dummy variable here. You have to put something in there just because you want to say it's this function, this acceleration function, but we can't use t because we're using it up there for our function. When we actually work out what that function is, we plug it in, right? You sub it in here because you're evaluating that, and you're subbing in the t, right? You put a t in here, and then you put a 0 in there, and you get this function. That's the function we came up with last time, but we just kind of wrote it from intuitive understanding of velocity. To get the net change in position, which is what this is, right? This says how far did the car travel during those 8 seconds? How far did you travel is the same as saying what's the net change in position. The net change in position, I started writing it out down here. The net change in position is the integral of the rate of change of position, or in other words, the velocity. The integral of the rate of change of position, or velocity there, from 0 to 8. If you want to work this out, you are going to get, you use an antiderivative of that function, which is the same thing we had before, 5t plus, what was this, 0.4 t cubed. And we don't have to worry about a constant because we're subtracting here. We're going to use 8. The units are this. The units of this velocity were miles per hour. If we integrate this where these are seconds, this is going to give us miles per hour times seconds. Or in other words, miles per hour on the bottom times seconds, which are weird units. But we'll get the number and then we'll convert it after. That's the safer thing to do. If you evaluate this, you get 5 times 8 plus 0.4 times 8 cubed. And whatever that's equal to. You don't need to put the 0 in because it's just going to be 0, right? I'm not even bothering with putting that in. Right? Because it's going to give you 0 minus 0 if you really want to. What does that give us? 40 plus something? About? Somebody? Okay, 244.8 miles per hour times seconds. If you want to make it just miles, you can times by 1 hour over 3,600 seconds, right? Because that's equal to 1. No, not times by anything. We have both the units in here, right? It'd be better if you guys didn't talk during this. You have both of these units in here. If you times by 1 hour over 3,600 seconds, you got seconds on the top and seconds on the bottom, and you have hours on the top, hours on the bottom. It's just going to leave you with miles, which is what you want because that's position, right? So basically you divide this by 3,600 afterwards. The problem before was we divided this by 3,600, but then raised it to the power of 3 here, so it exaggerated the difference. It was wrong. This is like 0.068 or something?
Yeah, and the answer you got before was 0.011.
Yeah, I got 0.011 because it made this basically worth absolutely nothing. What is this, 0.8068 miles or something like that? That's how far it went. Does that sound like it makes sense? It's still pretty small, but it's only 8 seconds, and it's starting from 5 miles an hour, right? You know, a tenth of, well, it's not a tenth of a mile. It's between a tenth and a 20th of a mile. That's how far it travels during 8 seconds. It goes up to 81.8 miles an hour, but it started at 5 miles per hour. It started at basically walking speed or something like that, right? What's up?
Okay, so you know how we started at 0? What do you do if it starts at like 1?
Well, you could
Then you put 1 in there and subtract it.
you could say velocity at 1 plus the net change from 1 to t of whatever that was, acceleration of, except we got to do our dummy variable here. I think what you could, I mean, it doesn't matter what variable you put in here, right? W, A and W, A, W, D, W. I mean, you can pick a dumb variable, right? A dummy variable, whatever you want. It's not a dumb variable. This will work as long as this is what it was at 1, and then the net changed from 1, right? Okay? That'll give you the same function. It should give you the same function there. Now, I don't want us to get hung up on that unit changing thing there.
You times in the t, and then you times in the 0, and then you just cancel everything because 0 was there.
Well, in this particular function, when you put 0 in, it's nothing, right? No, you'd have to put the 1 in there, right? And that would account for the fact that this would be different. So basically, you'd be putting in what it was at 1, but then subtracting it off over here. I mean, it depends on the function, right? That's no fun. What an insult. Okay, I do want us to look at this one, but it would probably be safest to stop this and start again here. This